Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hello, guys, and welcome back to this amazing channel. This is Abhinav. Today, we are back with our next problem of the day, which is min time. It's actually a really complex problem if you will see the implementation part, based somehow on DP concept, but for sure, we'll solve this problem. Okay. Hi, Risit. Hi, Amit. Hi, guys. I hope that I'm clearly audible and visible to you all so that we can start today's class. Please let me know if I'm clearly audible and visible to you all. Okay, fine. Hi, technical Jethia. TMKOC fan. Okay, it's hurting. Fine. Audible and visible? Great. Amazing. So the problem today is min time. It's a median level problem. The problem is completely based on the implementation that how you are implementing it. Uh, I figured out multiple ways how to solve this problem and come up with a basic solution. So let's discuss that. Let me first share the screen and we'll discuss about the problem. Problem says that there's some location present on the x-axis, okay, and there are fruit, and every fruit has a type. The thing is, you have to take that fruit starting from the zero coordinate, again come back to zero, but the fruits which you have to take should be in increasing order, or you can say a non-decreasing order of their type. So basically, first you have to take all the fruits of type 1, then type 2, type 3, and so on. So you have to take the fruit of each type once. Let's say that, okay, wait, my editor is not open. Let me open the whiteboard. So I hope, first of all, is the problem clear to you all? Like, how many of you are clear with the problem? And how many of you are who are even not clear with the problem, what the problem says? So you have to go through all the fruit, but in a non-decreasing order of their types. Are you getting? So it basically means that first of all you will take all the fruits of type 1, then all the fruits of type 2, then 3, and then so on. How many types like types are there? Okay. So I hope that this should be first clear. That's the first step of your problem. Yeah, we can have a sample case. So yeah. So see, the sample case is, let's say that n is equal to 5, means we have 5 fruits. So see, n is equal to 5 doesn't mean that we have 5 types. We have 5 fruits. Okay. So let's say that location of the fruit that is given to us is something like this. So they are at location, it's like this. So let's say it's at 1, 3, 5, 6, 9, and 12. Okay. And fruits are like this. So fruits are like, this is a type of 2, type 1, type 2, type 3, type 1, and type 2. Okay. There are 6 fruits now. Yeah, I guess it's fine. Okay. So this is how we have. So they want us to take this fruit. We have to start from zero. We have to start from zero. Okay. And each step takes one step. Okay. So what they are saying is that we have to take the fruits in non-decreasing order of their types. So these are the types of the fruit. These are the types. So guys, what happens is, uh, what happens is that, let's say you have something like, uh, we have 3 types: type 1, type 2, and type 3. So types will be most probably from 1 to there only. Okay. So now what we will having is, so first of all, you have to take all the fruits of type 1. So you can see type 1 fruit is at 3 and at 9. So means overall it will take 9 distance. I'm counting the answer here to move from 0 to 9 and take a fruit of type 1. Now next come fruit of type 2. So fruit of type 2 are where? So first fruit of type 2 is at, you can see it's at, like there are three fruit of type 2. One is at 2, then 5, then 12. So how should we go so that we can get a minimum distance? So let's say first of all we are going up to 12 plus 3, then we are going to 5 plus 7, like because from 12 to 5 the difference is 7, and then from 5 to 1 difference is 4. After that we will have a fruit of type 3 which is at 6. So now we will go to 6 with distance 5. So this is the overall distance that we have. If you will find the answer for the sample case that is given to us, you can see for that case what is the location. So for this case, location is 1357 and types were something like 1, 2, 3, 1. So first of all, we'll take the type 1. So type 1 is at 1 comma 7. So means from 0 to 1 then to 7. It will take 7 seconds. Then we have to take type 2. Oh, sorry, type 1. And type 1 is at, oh sorry, type 2. Okay, yeah. Then we take type 2. So type 2 is at 3. So now from 3 to 7, it takes 4. Now see guys, we will see that which is close, whether 7 to 3 is close or 1 to 7 is close. It is also possible that we are going from 1 to 7. Like see, एक पॉसिबिलिटी क्या है? एक पॉसिबिलिटी ये है कि पहले हम 1 पे गए, फिर 7 पे गए, फिर 3 पे आए. Second possibility is first we go to 7, then 1, then 3. So you can see that 1 is close to 3. So first we will go to 7, then to 1. Like I can say we can start from 7 itself, because I think that they are not saying that we have to start from 0 only. Okay, so we are initially at 7. Okay, so because we are initially at 0 only, so both the case will take the same time, I guess. Yeah. So I guess that is what we will do. So what we will do is that first of all we'll be having from 0 to 7, then from 7 to 3, and then from 3 to 5. So 3 में क्या है 2, 5 में क्या है 3 वाला, और यहाँ पे 1 वाला fruit है. So 2, 3 mean 4 plus 2. So overall you can see it's having 18 exactly. ठीक है. So this is how guys it basically happens. ठीक है. So you can see here what is happening. First from 0 to 7 to take the fruit of type 1. Then at 1. So 7 plus 4 plus 2 plus 5. Okay. This is how it's giving 18. So the thing is that. So the thing is that one by one you have to take fruit of every type. So see, one thing if you observe is that when we are taking the fruit of 2, so we have 3 fruits of 2. Starting from 1, I'm removing everything else. So you can see that there are 3 fruits of 2, starting from 1 going up to 12. Once they start, so there are 2 ways to take this 3. Either start from 12 and go like this, or start from 1 and go like this. It depends कि close क्या है, कौन सा pass में. We'll go there only. Okay. So guys, we will first of all find the left extreme and right extreme of every type. Okay, let's say type 1. So type 1 is from 3 to 9. Type 2 is from 1 to 12. Type 3 is from 6 to 6. Is this clear? What I'm trying to say with this left and right extreme? Everyone? Please let me know if it is clear. We have only 2 viewers left. Is it clear? This much, guys? So first of all, we'll try to have the we'll try to find the extremes of every type. Okay, so like from where it's starting and till where it is going. Okay, and so for finding this, yeah, location is sorted, and I guess location should be sorted. Yeah, location is sorted. By the way, it doesn't matter whether it is sorted or not. I think yeah, it doesn't matter actually. We have to just see Uh, yeah, let's see. So the first thing that we will do is, in this particular case, is we will find the left and right extremes. Okay. So for that I will use a map. So like for every type we will have two things. Now. So like we will have a map of. So first of all, as we have to make it, as we have to use long everywhere, I'm defining long with LL. It's then easy. So it's simply type define long LL. Okay. Now we will have a map. Sorry. Yeah. Great. So we will have a map, and the map will be of LL. Yeah. So map will be of LL, and each map will have two things, two values. What? One is the left extreme and right extreme. So we'll have a vector, and like we can take a pair also, but I'm having a vector. There's a reason, because after that we have to insert it in a vector itself. Okay. So that's the first thing. Yeah, exactly. We have to first find leftmost and rightmost location of each fruit, so that we should know. If we start, like, first of all, the first thing that we will know by using this is that which is close. Let's say currently we are at 5. Currently we are at 5. So I will check whether the leftmost is close to 5 or rightmost is close to 5. So if, let's say, rightmost is close, so we start from rightmost and we move to the left extreme. So that is what we will do. Okay. So I will first go through all the fruits having the locations. Okay. So first of all, I will have a type. What is the type of the fruit? Okay. After having that type, I think next thing is the position. Let's say the position of that particular fruit. Okay. So type is done, position is done. Now if MP finds that type, like if MP has that type, are you getting? If MP find type is equal to mp dot end, मतलब अगर वो फाइंड, अगर टाइप पहले से था, अगर टाइप पहले से था, so either it is a left or it is like, or let's say if it is not present, like if mp dot find is equal to mp dot end, that means वो टाइप पहले से नहीं था, like this, it doesn't exist already. So if it doesn't exist already, I will simply exist it, and I will simply make this position as both right and left extreme. Like say, let's say that if 3 is present only one time. So for 3, 6 is the left extreme only also, and 6 is right extreme also. But let's say first time when 2 is there, I will assume 1 and 1 both as is its left extreme. Now let's say again 2 came. This time it is having a value 5. So because 5 is greater than this 1, I will make it as its right extreme. That is what we will do. So if the value is already present, so first of all we'll check for the left extreme. Let's say, so left extreme value should be the minimum of its previous value and its current value. Let's say its previous value is something like this, and current value is like this. And if we talk about the right extreme should be maximum, rightmost. Is this clear how we are finding the right and left extreme? Please let me know. Is it clear? Everyone? See guys, it's a difficult problem. Okay, we all know. So we have to go step by step, and you guys have to tell me everything. Okay. Don't directly jump to code. Like, I'm not much coding much. I have explained everything, I guess. So I'm going step by step. Like first of all, currently I've done nothing. I'm just telling how we can find the left and right extreme. That I have already explained, Amit. I hope that should be clear at least. That like we are finding just the right and left extreme of a type. Is that not clear? It's difficult, I know, but see, currently we are just finding live left and right extreme of every. Let's say that 2 is here. So for 2, its left extreme is 1. Like the leftmost position where 2 is present is 1. And the rightmost position where 2 is present is 12. That is what we are doing. So for 3, its left and rightmost is 6 only. For 1, its leftmost is 3 and rightmost is 9. That is what we are finding. So for every element, for every type, we are finding its left and right extreme. Is that also not clear? So like we are just simply finding the position and the type. So if that type is already there, we will have the left extreme. This is the left extreme and this is the right extreme. Left extreme means the leftmost position, the minimum position, and right extreme means the maximum position, rightmost position. At least respond if it is not clear or if it is clear. Okay. Great. So now what we have to do, guys? Now we have to iterate through this these left and right extremes. So like for this particular problem, what will happen is that we will have 3 extremes. Okay. If you will see, तो हमारे पास क्या होगा कि so now what this extreme means. So let's say when I'm saying the value of MP1 is when I'm saying the value of MP1 is 3, 9. So that simply means that 1 is from 3 to 9, something in between. That's the left. If I'm saying MP2 is 1 to 12, that means for 2, we have to start from 1 and we have to go up to 12. Similarly, if we talk about MP of 3, it's from 6 to 6, means we have to start from 6 and go up to 6 only. That's only the range of 3. Okay. Now what I will do, guys, from where we're starting. So we have to start from 0, 0. Okay. We have to start from 0, 0 means we have to just cover this range 0, 0. After covering 0, 0, next we have to cover is 3, 9 because we have to go type wise. We have to go in an increasing order of type. So first of all, we will have the type 1. So for type 1, for taking type 1, we have to start from 3 and go to 9. That's the first case. Then we have to start, then the next range is from 1 to 12. At that we don't know whether we have to go from 12 to 1 or 1 to 3. Because see, when you will start from 0, first you will go here 3, then 9. Then you will see that 12 is close to 9. So 9 will first go to 12, then 5 and then 1. But how we have to figure this out, that we will discuss in the upcoming time. But for now, that's the thing. Okay. So, and then we have to cover the range of 6, 6. And again, you have to go to 0. So that is something what you have to do. This is something you have to do. Okay. So I have to first make this vector that will tell us from where to where we have to go. So I will create a vector, 2D vector. You can see it's created. Okay. Please tell me at any point when you have any doubt. Okay. So this is a vector that we have created. Okay. Now this vector will first of all have a 0, 0 means as we are starting from 0. So both the left and right extreme are 0. We are assuming. Okay. Initially. So it's 0, 0. Now what we will do is, now I will iterate through this map. Okay. And I will push the values of this map. Like values means 3, 9, 1, 12, 6, 6. Like means these are the ranges where we have to go. Okay. And after that, again, we have to push 0, 0 because again, we have to come back to 0, 0. So this was our overall setup, what we have to do. Is this much clear? Everyone? Okay. Now, guys, next point is something complex. Now we have to declare a DP state and we have to solve our problem. So अब देखते हैं क्या होगा. The next point is something that we have to discuss. अब देखो next क्या हो रहा है यहाँ पे. अब देखो this is something going to be difficult. Okay, I know. So देखो अब let's say कि ये हमारी है रेंज, ठीक है. You started from zero. You started from zero, and you have to first take one. So let's say कि because we know if one is the first type, so you first started from zero. You took three, and you took nine. So means both the ones are taken. Both the ones are taken. Okay. So you took three, you took nine. There are two ways to do this. And either you take in first three and then nine, or either you first take nine and then three. So it depends. Now from this nine, you have to choose where to go. So next, this was type one. This was type one. Next, you have to go for type two. For type two. But which side? Type 2 has two extremes. One is 12, one is 1. So which extreme to take? That is something we have to figure it out. See, what I will do, I will take a DP state first of all. 2D DP vector, I will tell you what it will do. This DP vector will also have, first of all, it will have a size of equal to number of types we have. So this V vector is having all the types. So it will have the size of it. And it will also have that same vector of size 2 that will denote the left and right extreme. Okay. Now what will happen is I will iterate for all the types. So I will start from type 1 and I will have for all the types. Okay. I will have all the types here. Now for every type, see guys what we will do. We have four choices. For every type, we have four choices. See what's the first choice. The very first choice is that, first of all, let's say you are taking choice A. So in choices, you will first of all, let's say that previously you are at extreme 0. Let's say you were at extreme 0 of your previous. So I am taking dpi minus 1 0. ठीक है. अब देखो, what is happening is, let's say you are at here. We have two choices. Either, see, we have two choices. Either we move from this point to the first point of our current. So can you please tell me, if we are at type 2, so which is the left extreme of type 2? So you will say that the left extreme of type 2 is 3. So I am saying, let's assume if I am at the right extreme of the previous type, and I have to go to the left extreme of the current type, and then from the left extreme of the current type to the right extreme of the current type. That is what we will do. That's the first case. The first case is that, let's say, what I'm saying, I will again explain it to you. Let's say that current type is 2. Means currently you are taking for a type 2. Previous type was 1. So I'm saying, let's say that you ended up at the rightmost position of your type 1. Now you have to go for type 2. Now for type 2, you are choosing the leftmost position first. Like you are first going to leftmost position of it, and then from leftmost to rightmost. You are going like this, left to right. So how much time it will take? So it will take, first you have to go from the right extreme of the previous to the left extreme of the current, and then from the left extreme of the current to the right extreme of the current. Are you getting it? Please tell me. मतलब आप कहां थे? Let's say that this was type 2. This was type 1. This was type 2. You are here. So first you have to go from the right extreme of type 1 to right extreme of to left extreme of type 2, then from here to here. So this distance and this distance. From left to right extreme to left extreme of current, then left extreme of current to right extreme of current. Yeah, so that first part, see, this is something, these are the number of seconds or the time that it took for till I minus 1 टाइप्स. इतना टाइम उसको लगा i minus 1 टाइप्स तक आइट्रेट करने का. अब वो ith टाइप पे आइट्रेट कर रहा है, बट जब वो ith फ्रूट पे आइट्रेट करेगा, ith टाइप वाले फ्रूट पे, तो इट शुड फर्स्ट नो कि वो i माइनस से उसके लेफ्ट एक्सट्रीम पे जाएगा कि राइट एक्सट्रीम पे जाएगा. We will see both the cases. Yeah, we can go right also first. I will cover all the 4 cases. See, we have 4 cases. Yeah, second part is to cover all the fruits of I. Exactly this. You got it. You got it. So Amit, we will cover all the cases. We have 4 cases, guys. देखिए, first case क्या है? First case is that, let's say this is the, see, I am explaining like this. Let's say this is the previous, this is the current. Okay. So see, first case क्या है? What is the first case? So first case is that previous के right से current का first and then here. So what I'm saying? Previous right, current left, and then current left to current right. This will be common in all the cases. Okay? This is the first case. Second case is previous का right to current का right, and then again same current का left to उसका left. ठीक है? Third case, previous का left to current का left, and then same. And fourth is previous का left to current का right. Are these all the 4 cases clear? Clear है? These are that 4 cases that we have. Tell me, is it clear? Okay, great. 4 cases clear. See, this is the first case. This is the first case. The first case says that, yeah, the first case says that you are previously, you are till the left of that case, you have taken till here. Okay. Now what you are doing? Now you are moving from the, you see this one indicates the right. See, this one indicates right extreme and left indicates left extreme. Means, okay, means previous case ka right to current case ka left, and then this is common for every case, that you have to go for like this thing. Yeah, this is common for every case, that you have to go for left to right of that particular current case. Okay, that's first thing. Now second thing is, wait, okay, now second thing is that you are at, let's say LBB, that you are at, like first take element 1. Now it's saying you are at the left extreme of the previous, and you are going to the left extreme of the current. So this is the case here. The case is left extreme of the previous to left extreme of the current. This is the second case. Okay, and here also then you are adding the ABS of from left to right of the current case. So these both the cases are where, so देखो, see, in these both the cases you will ultimately reach where, you ultimately reach right का 0. Okay, I've done something. Oh yeah, so देखो, why I'm writing here dp of I का 0 is equal to, and you want the minimum of that ना, so you will take minimum of A and B because you want minimum time. अब देखो, why I am writing here dp of I0. I'm writing here, yeah, it is like that only. Oh, sorry. Yeah, it should be like that. Yeah, sorry, exactly. Now, see guys, in these both the cases, What we are doing is we are going from like v of 0 means the left case. That is why we are taking here dp of I0. Now in the another case, what we will do, I will have a c. So what c will have, c will have I minus 1 of 0 here also. Okay, now this will first add, this time we are having from I minus 1 ka 0 but going to right. तो यहां पे क्या कर रहे हैं, we are having from v minus 1 का 1 minus v का 1. Are you getting? So right of previous to right of current, right of previous to right of current, that is what we are doing here. It should be, it should right, it should be right of previous to right of current, then plus the same value. And similarly in D, this will be right. Okay, and it should be ABS of, it should be ABS of left of previous to right of current, but both the cases we are right of current. And then add this part, and then our dp of I1 will be the minimum of C and D. And then at the last you will tell, for the last means time required to reach the very last node. So you will simply return the value of dp v dot size minus 1 means time taken for the very last to go, means the time taken by the last type, last extreme. That will be your answer. So it took around more than half an hour. Yeah, so it's clear. So you can see that the, if we talk about a time and space complexity, line number 39. No, it should be, so it's something you will see opposite. So it seems ki we are starting from there, but it's something opposite. Because if we are starting from there, it should be stored, this dpi minus 10 stores at, see, we are, we should have end here. So हमें, so देखो, if we are starting from the right of I minus 1th type, that means we should have started from the left of I minus 1th side. You know, हमने start कहां से किया होगा, हमने start किया होगा I minus 1 के left से, तब हमने I minus 1 के right पे आके रोका. So it's something opposite. You think? That's the, so you can see here we are starting from left of I but ending at right of I. Then also we are storing in dpi0. So like if you have any confusion, you can change this 0 1 for all the cases, then it will run. So guys, if we talk about time and space complexity, it's order of n both the cases. Okay, we are not having any other both the thing order of n, but yeah, the problem was quite complex. If you guys want, I can share with you the code. So yeah guys, here's the code. Okay, so that's all for this particular session. I hope the problem is clear. The problem was quite complex today, but yeah, I hope that it is clear to you all. Let's meet again tomorrow with the next problem of the day, which seems easy to me. Okay, tomorrow one is quite easy. uh, that's all. Thank you. This class, have a good day. Bye.